Okay, here's a little bit of help with Lab 1. You'll see in the Moodle page there's Lab 1 that you open, and there'll be 4 items, but the first 2 items are related to this document here, so let's open that document. The first question is answered entirely in the first 2 pages of this document, so you just need to read through this, and I think it's the first 2 pages. Well, this maybe isn't paged off. And then you come to page 3. It's not showing up right. But anyway, where you have task 1, and that's question number 2 in the lab. And so you just read through this and you fill this out. You delete the first 2 pages of definitions of terms, right? And you save this either as a Word document or a PDF, and you type over where the XXX's are, you type over all your measurements, and then you show your calculations, and you finally come up with a final answer and the percent difference and all that. If you have any questions about this, you should ask me by email, but remember, in this exercise, you're paying attention to significant figures, you're using your ruler, you're measuring between the lines, you're getting as many digits as you possibly can by reading between the lines, going to what's called the doubtful digit. So if you don't show enough digits here, and you don't follow the rules of significant figures based on your measurements and all that, then you won't get full credit. So if you have any questions about that, or you want me to look over your document before you submit it, you can email it to me and I'll be happy to look it over before you submit it. Okay, so that's the first 2 items. Now we'll go to the 3rd and 4th item, which is part of the Compadre Fizzlet simulations. So let's go there. Actually, we're not there yet. Here's the, I'm in the lab now. And what you'll see is these blanks. There's multiple choice questions. There's fill in the blanks. A blank will only take 1 word. If a blank is a number and only a number, you must only put a number in there or it won't read it correctly. Like down here, you see you want to put a number in there and the unit is already there, so don't try putting the unit in there, otherwise it will reject it. Here's a percent, but the percent is already there, so don't put a percent in there. Okay. And so that all gets answered in the first 2 pages of the lab document. Here's where you submit that 3rd page that we just talked about. You submit it as a Word or a PDF document. And then we move on to the 3rd question, where there were 4 animations, and you have to insert a number in these 4 boxes for each of the 4 animations. So now let's open that animation. Actually, before I do that, let me just show you this, because so we're going to come up with 4 numbers, 1 for each animation, the length of the object using the vernier calipers, in case I don't get back to this screen. And then here, you'll notice the blue note about caution about filling out these boxes, like I mentioned before. No more than 1 word in a box. And if a box wants a number, you need to put a number in there. Like here, this box wants, whoops. This box here wants a number in meters, so you put the number in meters. This box here wants a number in seconds. That's an error. I typed that in to show people what not to do. That shouldn't be there. There should be a number in there. You're going to convert the number of seconds in an Earth year. You're going to calculate that and put the number in there and use the scientific notation. And the scientific notation, how to do the scientific notation is explained here. Use this form, not times 10 to the times 10 to the 5th. No, you use, if this were the number, it would be 3.2 E5. E5 means times 10 to the 5th. So that's the notation that Moodle wants for these questions. And so just be careful. When it asks for a number, put a number. And when the units are given, it means there's no units go in that box, just a number. Okay, so we're going to have to fill out all these blanks for the second simulation. Now I'm going to go to the simulations. Okay, this is going to look a little different from what you go when you go to Compadre. I won't explain why, but I had to go here. And when I try to close this, I can't close it. So anyway, when you do it, you'll grab this red button and you'll close it and then you'll read it. But we can learn how to read this anyway, just from where it's set now. Let's read the gap it's at. So what you do is you look at this 0 on the sliding scale. This scale will slide. So you look at this 0 and you read up. And right now it's at 2.123, and it's pretty much exactly 3. So if the position were here, you would read this 2.30 because it's exactly on the number. And if it were a little bit this way, we would use this scale here to read between the lines. So let me see if I go to the next animation, if it gives us the chance to do that. Animation 2. Once again, I can't slide this. But in this case, it reads 3.3 exactly. Okay, and I can't move it to help you. Maybe I'll do a drawing if I can't. Let's go to animation 3. In this case, it reads exactly 0.3, so it would be 0.30. The problem is, in every case, it's exactly on a line. What happens when it's not on a line? And also, in this case, what you would do is you would take this slider and slide it. So this mechanism allows you to measure the inside dimensions of an object. And so you'll do that here. And then when you get to animation 4, you'll have to slide the car into place, but in order to slide the car into place, it does allow me to do that, you have to grab this little red button and open the caliper up and then close it. And the key to this one, where people mess up, is that when you grab the car and slide it, you've got to make sure that it's right exactly. So if you bring it too far, it's no good. If you leave a space, it's no good. So you've got to put it exactly flush against the thing and then put the backside exactly flush against this edge to get the correct measurement. Okay, let me do a figure and show you how to read this caliper when it's not on the line. Okay, see if you can follow this. So this bottom scale is what slides, and you read off the 0, right? This would be 0.30 because it's exactly on the line. But let's say we slided it down so this 0 line were here, and it didn't fall on any line. It fell between 2.1 and 2.2. So you're trying to estimate this space, and it looks like it's in the middle, right? So you might say 2.15, right? This would be 2.10. This would be 2.20. This would be somewhere between 2.10 and 2.20. So we might guess that it's 2.15, but you can use these lines to find out. So when you look down the lines, none of these lines on the sliding bottom scale line up with another line except for these two. That's what you'll see. And this is the fifth line, right? 1, 2, it's the fourth line actually. No, that's the 0 line. So that's 1, 2, 3, 4. So the 4 line here lines up. And so what that means is you would read this not as 2.14. It gives you better precision at estimating that doubtful digit between the lines. That's how you're supposed to use this caliper. Okay, that's the best I'm going to be able to do here. Let's move on to the next simulation. Okay, this is the simulation for question number 4. And there are 3 objects. The yellow one is supposed to be a star. The little figure is a person. And the tiny red thing at the bottom is supposed to be an electron. So it's just to show you if we're measuring motion over many scales, we might have different scales of measure for the grid that we're looking at. And if we play the simulation, you can see things move. You can pause it at any time. You can step it back. You can step it forward. You can reset it. And so you'll be running this simulation and taking measurements. The measurement you'll be getting will be time and distance. And the time is at the top. And if I put my finger on here, you may not see it. There's a cursor. Right now I'm running my finger on the screen, and you see those yellow numbers at the bottom? That's showing me the position of my finger. So what you want to do to get the diameter of the star, you want to put the cursor at the bottom, and you'll see that the position is right at the center. Actually, it looks like it's going to be 0, 0, and then when you go up to the top, it's going to be 0, 14. So you can get a measurement. There's a little bit of uncertainty in that measurement. A width of 14 across the star. And if you measure like the starting position of the person, and then you measure the ending position of the person, you can get the distance that the person moved, or the star moved, or the electron moved, and the time will be displayed at the top. However, keep in mind that the distance, the scale for the distances is given down below, and it's only meters and seconds for the person. It has different units for the other objects, and so you need to read this to get the units for the other objects. And remember that when you're writing numbers in Moodle in scientific notation, if it's 10 to the 8th meters is the distance unit, that's going to be 1e8, right? The same as 1 times 10 to the 8th. And here the units are meters, so just use the right formatting. Okay, I think that's it for this one. Remember, just be careful, like I mentioned earlier. If the box wants a number, put a number and nothing but a number. And if it wants a word, just put a single word. All right, maybe I forgot something, but I can't think of it now, so I'm going to stop.